This is a second example of the technique of linear programming, and this is taken from the textbook Math in Our World, page 394. A local animal shelter receives at least 4 cats and 7 dogs a day. The shelter has the capacity to receive up to 30 cats and dogs a day. If the shelter can raise donations for the animals at a rate of $3 per cat and $7 per dog per day, how many cats and dogs should the shelter accept to maximize the amount of donations per day? So step 1, identify the variables in the problem. What do you need to find? All right, looking at the last sentence, we need to figure out the number of cats and dogs that the shelter should accept to maximize the donations. So we'll let X be the cats and Y be the dogs. Part B, we need to write an objective function. So in this problem, we're trying to maximize the amount of donations per day, so that is our objective. Right? So we want to maximize donations, so I'll write a function for the number or the value in dollars of the donations. Alright, so I need something in terms of X and Y, and if I look back a sentence, it tells me the shelter can raise $3 per cat and $5 per dog. So 3 times the number of cats plus 5 times the number of dogs will give me the total number of dollars of donations. And then part C, write the constraints as linear inequalities. So I'm looking back through this problem for any restrictions or limits on the cats or dogs or other things in this situation. Alright, so the first sentence, the shelter receives at least 4 cats and 7 dogs. So that means that the X, the number of cats, must be greater than or equal to 4, and Y, the number of dogs, must be greater than or equal to 7. Alright, so let's pause for a minute here. We also have those understood restrictions that X and Y have to be greater than or equal to 0. But notice in this case, if X is already greater than 4 and Y is greater than 7, then we don't really need to consider X and Y greater than or equal to 0 because we've already stated it. That would be redundant. Alright, so we've taken care of those, and then we move on. The next sentence, the shelter can receive up to 30 cats and dogs per day. So we have one more restriction, and that's that the combined number of cats and dogs, X plus Y, must be less than or equal to 30, since the shelter can receive up to that number, but no more than that. So now I have 3 constraints to graph, and I'll go through the steps in graphing this, and then you could either describe these steps on your own or just submit an image of what your graph would look like. So we have X greater than or equal to 4, Y greater than or equal to 7, and X plus Y must be less than or equal to 30. Alright, so the first one, we could graph the boundary line, X equals 4. That's about here. Okay. And then if X is greater than or equal to 4, I would need to shade to the right of that line. Then Y is greater than or equal to 7. That's a horizontal line here. And if Y is greater than or equal to that, I would need to shade above that line. And then finally I have X plus Y is less than or equal to 30. So I could look at the boundary line, and I could either put this into slope-intercept form, or I could also just choose points that work for this equation. All right, so if I do slope-intercept form, I'd have Y equals negative X plus 30. So I'd need to graph the y-intercept of 30, and it looks like that would be off of my graph. All right, so I may not choose to do that in this situation because I've made my graph too small. So instead, let me just look for some points that make this equation true, and I'll try to choose things that actually are on the graph. All right, so if I choose X is 10, that means Y has to be 20. And I can sort of fit that on there, but it's kind of at the top, so I might want to choose a few others. If X is 15, Y is 15, that should work. All right, that would be 15, 15, that's here. Okay. And then if x is 20, y would be 10. And I think that one will work as well. Okay, 20, 10. All right, so let me put a line through those points. All right, and then for shading, x plus y is less than or equal to 30. I could test 0, 0, and I'd need to be below those points. All right, so if it looks like where these three inequalities overlap would be this region in here. Okay, and I can see two of the vertices. I have this point 4, 7, and over here, that is the point 23, 7. All right, but I have one more vertex that's kind of way up at the top, and it's run off the graph. So to find this one, I have a couple options. Again, either just draw your graph on a larger piece of paper and you would be able to see what that point is, or I could use something from algebra. I could try to solve and figure out where those two lines cross. So I want to know, where does x equals 4 cross x plus y equals 30, and I can use substitution. So in this technique, we combine the equations by substituting one equation into the other. All right, so my first one tells me that x is a 4, so in the second equation, I would just substitute a 4 in place of the x, and then solve for y. So that would mean that y would have to equal 26. All right, so that's my point 426. And I can check this just by seeing if that makes both equations true. All right, so 426, 4 does equal 4. And then in the second equation, 4 plus 26 does equal 30. So I know that that point is on both of those lines. Okay, list the vertices of the feasible region. So we have 4, 7, 4, 26, and 23, 7. All right, and then I need to test these vertices in the objective function to see which one yields the optimal value. All right, so I'm testing each point in that function for donations, which was 3x plus 5y. Okay, so 4, 7 gives me donations of, okay, 12 plus 35, or 47. 426 gives 12 plus 130, which is 142, and 23, 7 3 times 23, 5 times 7, that's 69 plus 35, which is 104. All right, so the maximum value is going to be that 142. It's the largest out of the 3 donation amounts. And then the maximum value occurs at 426. So finally, I just need to interpret what this means in the context of the problem. And this means that the shelter should accept 4 cats and 26 dogs in order to maximize the donations, and that maximum donation amount would be $142. And that's it.